This is our last free response, the one you guys have. As you can see, it's with graphing central linearization. So let's read the problem. For most springs, the amount of force the spring exerts is proportional to the distance of the spring stretched. However, nonlinear springs have a different force. A certain nonlinear spring exerts a force that is proportional to the square of the distance stretched. So we end up, it gives us this equation right here, where x is a distance, a is a constant. A student tests the spring to determine a and obtains the following data. What quantities should be graphed? So this is the linearization piece. Okay? We know we're always looking at, if I'm going to linearize it, I'm looking at y equals m times x. So you'll need to either have an equation, like the one we have here, or you may have to produce the equation. This one's nice because it gives it to us. So here we could look at, okay, the equation is force spring equals ax squared. So now, y-axis. Will this work for the y-axis? Do I have data that's changing for every single section that I have? So here's force of the spring, and it's always changing, so that will work on the y-axis. Okay, on the x-axis, if I'm dealing with the x-axis, okay, do I have data that's always changing for x squared? Well, I don't have x, but I could produce an x squared column. Okay? And I could make that data, so that could work. Lastly, what's on my slope? Okay? Slope is a, that has to be only constants. And a, it says a is a constant, so that will work. So if I had to graph this, we can even come back down here, because I know you're going to have to graph it next, as I'm going to I'm going to graph Fs measured in newtons. Then I am going to do x squared measured in meters squared. Right? Now let's get the numbers for this one. So I can go up and I can do all these calculations to find these numbers. Pause, give yourself a check, and then you will see my answers appear. Now, here's my data. Right? We already calculated what we would graph, so I got to double check that. That I have force, this is force of the spring versus x squared. Calculate the values. Time back. Next one, calculate the values. That's what we did up here. That are not given the data, and record these. Label the top of the column including units. So there's mine. You can pause it. You can do that so you can get the numbers. Now this one says on the axis, plot the quantities you are indicating in A. Label the axis with variables and appropriate numbers to fit the scale. So I can look up here, force of spring ends up at 106. So I have to make sure this gets into 106. Okay. So give yourself a shot and see what you can put on these so they fill up. Now this one took me a while, but I got my scaling done. So here I copied and brought my data right here to help me see. So my first one is 4. Right? So this is 10. So somewhere here, this would be 4. Right? And 0.0025, so that's going to be halfway in between. So right about there. Let me clean that up just a tiny bit. So let's, come on now. Again, small. Didn't make him in. Alright, there we go. The next one is at 17. So it's going to be a little farther up. And 0.01. So that's going to be right about there. Let me do this. So 0.01 plus, it's making me mad. This one? Is it right here? Well, it doesn't seem to want to be doing that, but you would have to graph these points. Right, try one more time, see if I can get it to work. Nope. Okay, so I'm not able to get this working, but you would plot your points. Okay? Then, if you were to plot your points, you would do a line of best fit. Let's try Let me do a straight line. Come on. Doesn't want me drawing this, but you would do a line of best fit going through this. Right. Oh, there it came. So there's my line of best fit. It needs to be straight. I'll have rulers. You can use the side of your thing. Something on that. Right. Now, if you have data points all around this thing, don't use them. When you calculate the slope, you would pick two locations, so a rise and a run, and solve your slope. So from this, we said m equals a, and slope is m, so that would be a. If you do this one correctly, you should get around 1700 roughly. The slope should be roughly 1700. When I calculated it with someone, I got 1600. So roughly pretty close to that, but it should be a large number. Good luck on your test. Hopefully these helped prepare you for the test tomorrow. Again, I'll be in